Hey everyone, welcome back to the channel. In today's video, we are going to solve an interesting coding problem that has been asked by the multiple companies. So the problem is called the count negative numbers in a sorted matrix, and it is also available on the lead code this question. We are given a matrix where each row and column is sorted in the non-increasing order, which is descending order, and we need to efficiently count all the negative numbers. So let's dive right into the problem and break it into uh, step by step. So this problem can be solved by multiple ways. One is writing nested for condition and checking whether it is greater than zero or not, which is a redundant approach for for if the matrix are too large. So it's not efficient in terms of the large matrices. So we will be following an efficient method which is called as bubble sorting. Sorry, binary sorting. We will be using the concept of binary sorting. So as we know, in the binary sorting we will be using two pointers approach. One is left, which will be 0, and the right will be the length of my list. And we will be finding the mid, and mid will be left plus right divided by 2. We will be doing floor division, so we will get the mid, and we will check the mid index element whether it is greater than 0. If mid is greater than equal to 0, sorry, if mid is smaller than 0, we will shift the mid shift the right as mid. We will initialize the right as mid, and if it's the not case, in the else part we will be writing else we will be shifting left equal to mid plus 1, and this we will be doing until when the left is smaller than right. The time when left is equal to right or greater than, then the loop stop. So the main idea why we are assigning the right, and so the right as mid is, if the mid is smaller than 0, let's consider now this mid will be some minus 1. So let's consider this as the mid position, and if it is smaller than 1, obviously all the elements which are after this will be smaller than 0, because given the list is a non-increasing order, it is decreasing order. Means if the mid is less than 0, then obviously all the elements after that will be 0. So we will be shifting our right towards the mid. And if it is the not case, and if it's not the case, then if let's consider our mid came as 1, so it is not less than 0. So in that case we will be shifting our left as mid plus 1, so that we will come ahead of the positive number, and this will be repeating until when the left is equal to right or greater than the right. In that case we will be approach if the left is not equal to right, or it is greater equal to right, or it is greater than right. In that case the left would be the first negative number. It will be first negative number, and to count the number of negative, we will just do the subtraction by length of my list minus the left. Here at the end of the iteration, the left will be the position where the first negative number starts, so that we will get the count of negative numbers. So the same which I said has been demonstrated here in the iteration wise. In the first iteration, the mid has been calculated. The mid index is 4, and if the index element of the mid, we take it as minus 1. So minus 1 is smaller than 0. So we will update the right equal to mid. So our new mid will be 4. So left will be 0. 0 plus 4 floor division by 2, we will get the mid index as 2, and the mid index element will be 1 in my case, in here in second iteration, which is non-negative. So we will be shifting our start position as mid plus 1. So in this case, mid plus 1 will be 2 plus 1, which will be 3. So we will be assigning the left as 3. So here we will be having 3 and 4, right as 4. So we will be finding the mid index element, which is 3 in this case, and 3 is 1. 3 is here 1, which is again a non-negative number, which is greater than 0. So we will be shifting our left as mid plus 1, which in the case is 4. The mid is 3 plus 1, we will get the 4. And here the loop stops. And here, as I said, when the loop stop, when the left position, we will get the left position where the negative number starts. So the 4 is the index where negative number starts in my list. So here the loop ends, and if you want the count of negative numbers, we will simply subtract the length of list minus the left point, which will be 8 minus 4. So there are 4 negative numbers in this. So the same we will transfer to the code using Python. So I will be defining a function count negatives. Inside I will pass the grid because the input is like that, and I will be defining another one function which will be used for passing the row from the grid. So count of negative in row, and here we will be passing the row. It will be taking row, and I will be assigning the left and right. The left will be 0 and the right will be length of row. And I will be writing a while loop while left is smaller than right. Until that, my loop should continuously run, and I will be updating my mid by left plus right floor division operator divided by 2. And if my mid index element row of mid is smaller than 0, in that case I will be shifting my right equal to mid, and if it's not the case, I will be shifting my left to mid plus 1, which is ahead of the mid. And I will be returning the length of row minus left. So by this, here left, when the loop ends, the left would be the index element of the starting of negative number, and when we subtract the length of row minus left, we will be getting the number of negative numbers in the list. And I will be initializing one variable which is total negatives. We need to calculate row wise. So I will be running a loop for row in grid, and I will be passing the uh, row by for loop into the count negatives in the row, and I will be updating what a scalar value will be coming, and I will be adding it into the total negatives. Count negative the row, and at last I will be returning the total let me try giving the input grid equals to, and output equal to count of negative by grid, and I will print the output. So we have achieved the desired output, which is 7. So there are 7 negative numbers in the matrix, and that's how we solve the count negative numbers in the sorted matrix problem. We explored how to take the advantage of the sorted property in the each row and columns, which helps us to come with the more efficient solution. The If you found this video helpful, don't forget to like, share, and subscribe for more problem solving tutorials. Thank you. Keep learning, keep coding.